Hi class, in this video we are going to be going over algebraic vector arithmetic. So instead of using graphs to add and subtract and scale vectors, we are going to do this component-wise algebraically. So here, let's work through this example. If v equals 5i plus 4j and w is 6i minus 9j, let's find the following. So A, we're going to find v plus w. Okay, so on the previous slide here, we have the definitions for vector arithmetic here. So now that we have our position vectors, we can do this algebraically, component-wise. So to add two vectors, v plus w together, I'm going to add the I components together, so a1 plus a2 of each vector, and the j components of each vector together, so b1 plus b2. So I'm adding what I call component-wise. Okay, so v plus w, rather, is going to equal 5 plus 6i plus 4 plus negative 9j. Okay, so to simplify that, 5 plus 6 is 11i. And now we have, for the j component, 4 plus a negative 9. So really this is 4 minus 9, which gives me a negative 5. So I get really 11 minus 5j. And that is the vector v plus w. For the next part B, I'm going to do something very similar. I'm going to do v minus w. So now the order really matters. So I'm going to take the I component of v first, which is 5, and then I'm going to subtract from that the I component of w, which is 6. So 5 minus 6i, and then plus 4 minus a negative 9, and that becomes my j. So 5 minus 6 is negative 1, so I get negative 1i, and then my 4 minus negative 9 becomes 4 plus 9, which is plus 13j. You could also write this as just negative I plus 13j, and that is my resultant vector for v minus w. On the next slide, I do have two more examples dealing with scalar multiples. Okay, and for scalar multiples, what we're going to do is a similar treatment. I'm simply going to distribute my scalar multiple to both components of my position vector. So to find 6v, I'm going to multiply 6 to the I component of v and multiply 6 to the j component of v. So if v equals 5i plus 4j, excuse me, then 6v is going to equal 6 times 5j plus 6 times 4, 6 times 5i plus 6 times 4j. So I get 30i plus 24j, which should be kind of similar to how we graphed these vectors earlier, where I had to multiply both the vertical and horizontal direction of my vector by my scalar multiple when I graphed it. Okay, the same thing is going on here, but now I'm just representing this algebraically. All right, so for part B, what's different here is now I have a negative scalar multiple. I'm going to treat it, though, the same way. That negative gets distributed along with my scalar multiple of 3 to both the I and j components of v. So negative 3v equals negative 3 times 5i plus a negative 3 times 4j. Okay, but negative 3 times 5 is negative 15, so I get negative 15i. And then negative 3 times 4 is negative 12, so that gives me negative 12j. And that is vector arithmetic.